Alright, this video is going to talk about finding the range. So, first we need to define what is the range. And we know that for this example here, it says find the range of a baseball is thrown with a velocity of 25 meters per second at an angle of 65 degrees. So, if we want to figure out what the range is, first we have to know what does range mean. And just from previous experience in life, you know that if there's this baseball, then it's going to follow some path. You know, it says I give you an angle of 65 degrees, so you kind of know 45 degrees would be like halfway between 0 and 90, so maybe this is 45. So 65 is a little bit more than that. And so if I hit this baseball, you know it's going to kind of go up, and of course it's going to slow down, and gravity's going to pull it down, and then it's going to come back down. And then hit the ground again. And so if we made a picture of its trajectory, it would look something like this. It starts here, it goes up, comes back down, and hits the ground there. And this shape, as we discussed before, and as you know just from math class, that this shape has a name, and it's called a parabola. This is a really important concept, that it makes a parabola, because we know about parabolas, which thankfully we do. We can figure out the range. So the range would be the distance that ball travels from here, from the starting point, to here, the ending point. That distance, whatever that is, that's the range. It might be, 400 feet if it's the Major League Baseball. They're going to hit it over the wall. So this represents the range, and that's what we're looking for. So let's just begin with writing those equations of motion that we've already discussed before. And again, if you're confused about writing those equations of motion, make sure either ask or go back and watch. There's a video on writing the equations of motion. So I'm just going to kind of go right into it. Of course, you know that we have to find the component first. So when I write these vertical displacement and vertical velocity equations, I have to find the vertical component of velocity. So I'm just going to do that right now. And of course I'm going to use sine. So Vy, what I'm going to call Vyi, the initial vertical component is going to be the initial velocity times the sine of 65, because again it's the vertical component that I care about here. So I punch that in, 25 times the sine of 65, and I got 22.65, we'll say it's 22.7 meters per second. So even though the ball is actually going 25 meters per second, it's going 22.7 meters per second up in the air. Up until this point, we haven't really used the horizontal component much, and we will use it at the very end of the problem, so I'm not even going to worry about it right now. Alright, so we have this. From here, we can write the vertical velocity equation, which of course will look like this. Vy equals Vyi, which we just found is 22.7, minus 9.8t. So that's going to be the vertical velocity equation. And then we can also find the vertical displacement equation. It's going to look like this. Y equals Yi is the height, which there isn't one, so 0, plus the velocity is still 22.7 times t minus 4.9t squared. If any of this is confusing, again, make sure you either ask me about it or go back and watch the video. You should, at this point, be able to write these equations pretty easily without really having to write out every single variable. And of course, I can drop the 0. I noticed that some of you were leaving zeros in, which is fine. It's not wrong. You can do that. And some of you had zeros in front of t. It's not wrong. It's fine, but you don't have to write like that. I could just write 22.7 minus 4.9t squared. All right, so now we've really got to think. This describes the height. This describes the velocity. Go back to the idea of the range. And let me just draw the parabola again so you kind of see. Right? It goes up. It comes back down somewhere over here. And we'll say that this is the ground. Now, how do you think I can find this range, this distance? Well, we need to define what is true. And by the way, I should go back. We were making one assumption about this, which obviously isn't true for a baseball, unless there's certain special conditions. But but we are making a certain assumption about what is going on with this range. And we're making the assumption that the ball is not going to move. It's just going to stay there, right? It's going to hit and it's not going to roll. It's just going to, like, imagine it sinks into the ground. It's really muddy or something. We're just not going to worry about the rolling. So when we define range, we're going to assume that all projectiles just stop on impact with the ground. So then, there's your hint. How are we going to measure this range? We need to know what? We need to know when the ball is where. And hopefully you Dora explored there and said the ground. It hits the ground, right? So when it hits the ground, that's when it's going to stop, and that's going to determine the range. Once you have this idea that we need to hit the ground, then which of these two equations am I going to use? Velocity or height, displacement, vertical displacement? And of course, it's going to be this. So numerically, what are we going to call the ground? Well, it's zero height, of course. So you have this. Let's plug in 0 for y. The initial height is 0. So we have 0 equals, I'm not even going to bother writing 0. It's still there, but we just don't really care about it. 22.7 t minus 4.9 t squared. And there you go. This is going to be a problem, though, because you need to solve for t. Just t by itself. Traditionally, if you've had a problem where you had to solve for t, what would you do? Well, you would probably try to get t by itself by maybe you would divide by negative 4.9, or you'd try to get this on the other side, or you'd have to take the square root. I'm telling you now that it's not going to be this easy. You cannot get t by itself simply through a traditional algebraic isolation. Now you can with something called complete the square, which you may have heard about in your math class, and you could do complete the square to figure out how to solve this t, get t by itself. The method that we're going to end up using is going to be, well, let's think about this, right? This is in essence showing the same thing that this is, okay? The reason why you can't easily solve for t is because there are actually two of them. If you just solve this equation, right, we're just trying to figure out when is the height equal to 0. Well, isn't there another part? At 0 it works, right? In fact, you could plug in 0 right now, and you would get, okay, 22 times 0 is 0, minus 4.9 times 0 squared 0. You just get, it's true, 0 equals 0. So 0, t equals 0 does work. Of course, that's not the solution we're looking for. But this is a quadratic equation. It makes a parabola. There's going to be another place where it crosses. You can think of the ground as the x-axis. There's going to be another place where it crosses the x-axis, and that's what we're going to be looking for. So this is where there are a lot of different methods that we can use to solve this. And I'm going to post that in another video, but I just want to show you the beginning steps. Let's pretend for just a moment that I knew the answer, okay? Because I want you to see the process more. We're going to worry about this step in a minute. So I'm going to pause the video, I'm going to calculate the answer, and I'll come back with the answer. All right, I calculated the answer, and I got about 4.6 seconds. So again, that answer is going to be about 4.6 seconds. And I'm going to go over in another video how we got that and the process to get that. Okay. Actually, before we start, before I move on, let me show you this. Okay, we got 4.6 seconds. If we take that information, we can actually calculate. Here are going to be the steps to find the range. Okay, and you can go ahead and write this down. We basically got through step 3. Find out. Step 4 is actually really easy. All we do, sorry about the announcement, guys. All we got to do in step 4 is we take the horizontal component, which I said we're going to use, right? Well, if we know it's in the air for 4.6 seconds, then it travels in this direction, horizontally, for 4.6 seconds. So if you want to find how far it moves, all you've got to do is take, okay, well, take that horizontal component, which of course we can find very easily, just 25 times the cosine of 65. Take that horizontal component, you get about 10.6, and multiply it by 4.6. And you end up with about 48.6 meters. So again, you can write down the steps. Please do write down the steps, and I'll have another video where I go into more detail on this third step, which is really the hardest step.